Hey guys, with this video we're going to start talking more about tangent lines. So let's take a look at the types of questions we're going to be working with. The first is something like this. This first one here, which we'll just zoom in on, would be something like this, where we've got PQ tangent to circle N, right? In other words, we were just told that this line PQ right here is tangent to this circle. The question, though, is based on that, what is NQ, right? NQ, which is this line segment here. Okay, so that's the first kind of problem we're going to be doing. So in other words, we're finding a length. The other kind of problems we're going to be doing is problems like this. Again, we've got a line here, right? ST, it's tangent to this circle. This time we've got circle Q here. But we're trying to now find the measure of angle T, right? The measure of angle T. In other words, what's the size of that? In other words, how many degrees is that? Okay, so sometimes we're finding lengths, sometimes we're going to be finding angles. All right, now before we do that though, we've got to think about what we can do that tells us that. I mean, right now, sure, we've got some lengths, but we need to figure something out. Well, there is something interesting. Notice, if you look at this, doesn't this sort of look perpendicular? This sort of look perpendicular. In fact, to me, it looks a lot perpendicular. Well, as it turns out, that's actually a thing. Well, we'll go beyond just saying thing. It's something called the perpendicular tangent theorem. Some people call it that. And so let's go ahead and take a look. Now, here's a particular circle. This circle, we've got this circle C. We've got a line AB. And it's just barely touching the circle. Now, before we go further, right, let's just remember the definition of a tangent, right? A tangent line to a circle intersects the circle in exactly how many points? Well, take a look here. To me, that looks like 1, and that is actually the definition. All right, remember this, write it down, take a break, pause the video. A tangent to a circle intersects the circle in exactly 1 point. That's what defines a tangent. Now, again, we're going to talk about one property of tangents in this theorem and this video. There's another one we're going to learn in the next one, but let's just focus on this one about perpendicular lines. Now, what we see here is what's going on. Now, this segment BC, of course, that's the radius, right? So it turns out a radius is exactly perpendicular to a tangent. And it kind of makes sense when you think about it, right? Look, I mean, if I was to start here, right? So here's this line AB. Now, if this wasn't perpendicular, think about what's happening here. If it's okay, well, great, I'm going to still touch it there. It's going to intersect there. But as I do that, notice what's happening. It's starting to cut off the line, the circle a little bit, isn't it? Right? So, I mean, you'd have to have a thinner line to see it, so I'll kind of exaggerate. But look, as this goes off a perpendicular, it's touching that circle more than once, right? That is no longer a tangent, is it? Same thing happens the other way, right? If I keep it touching there and angle it more, well, look, it's touching that circle more than one place. Now, if you get to the microscopic scale, even going off, just a degree, if you were to zoom in super tight and really look at that little spot there, what you're going to see is that it's actually now touching the circle twice. The only way to touch that circle once is for it to be perpendicular. Same thing goes here if you kind of think the other way too, right? So here's this tangent. Now, if we just kind of eyeball it there, right, I'd say that's right about where it intersects. Well, sure enough, if you just say, okay, there's that point, I draw it to the center, yep, that is the radius, and that sure looks to me like it's perpendicular. Okay, now, obviously, we'd want to do a more rigorous proof someday, but for now, let's just take it that that's the theorem, and we're going to work with it. So what we need to do is we need to write down a statement here. In particular, we've got the tangent statement, right? So there's two parts here. We've got AB, the line AB, is tangent to circle C, okay? And then we've got going to have an if and only if statement, right? I love if and only ifs, right? If and only if, remember, arrow going both directions means if and only if. If we have this line AB tangent to OC, then that gives me an if and only if related to the perpendicular statement. In other words, AB is perpendicular to BC, the radius, right? So that's pretty cool what's going on here, right? I've got this perpendicular statement right here, and then I also know that AB is tangent. So those go both ways. Tell me that it's perpendicular, and I'll tell you it's a tangent, or tell me it's a tangent, I'll tell you it's perpendicular. So it's kind of one of those bidirectional statements. So pretty cool. All right, let's start using that fact with a couple of problems. First, let's do some angle problems. All right, so the first problem we're going to do, let's zoom in on that a little bit so we can see it better, is this problem right here. Okay, so a couple angles. Notice ST here is tangent to circle Q. Okay, now let's see. Here's ST. Here is ST, right? Hey, what do we know? Well, ST tangent, therefore it must be perpendicular, right? Got to be perpendicular to there. Okay, so let's go ahead. Let me just mark that as perpendicular, right? We're using the theorem to say, hey, I know that's perpendicular. Well, hey, this is cool. What do I know when it's perpendicular? That means that's 90 degrees. And triangles, internal angles add up to 90. So therefore, or excuse me, 180. Therefore, these two acute angles must add up to 90. So we can either write it as it's adding up to 90, or another way to say it is, let's just say that the measure of angle T, right? The measure of angle T is equal to 90 minus 47, right? So the measure of angle T, which is this right here, this is what we're trying to find, the measure of angle T. All right, so, well, that's not too hard, right? 90 minus 47, let's see, right? That's just equal to 43 degrees. Okay, so measure angle T equals 43 degrees. That's our answer to this problem. And let's always put it, I always like to put it back in the picture just to double check, right? Does 43 make sense? Well, let's see, 43, 3 plus 7, that's 10, plus 1, 90. Yep, that seems to all look right to me. Okay, great. Let's move on to the next one. Now, sometimes it's going to be just a little bit trickier. We've got to do a little calculation, but again, let's kind of get our bearings straight here. We've got TU. Here's TU. This is TU right there. Okay, it's tangent to circle S, okay? So, hey, ooh, this is cool. I know what happens when things are tangent to a circle. The radius must be perpendicular to the tangent. All right, cool. Hey, oh, perpendicular, that means this is 90. That means these add up to 90. And so let's go ahead and do some calculations here and go ahead and write those down. So that means I've got 55. So that's this one, right? The first one right there, right? Here's 55 plus 7x minus 7 equals 90. All right, that's the equation we're trying to solve. All right, well, hey, that doesn't look too hard, does it? Let's combine like terms, right? 55 and minus 7 is just going to be 48. So I have 7x plus 48 equals 90, right? Well, cool. Well, let's get rid of that 48, right? Minus 48, minus 48. Subtract that from both sides. Okay, and so sure enough, I end up with then 7x equals, right, 90 minus 48. Let's see, there's a 2 there, and then there's another 4 here. Hey, I know, let's get rid of the 7 this time, all right? Divide by 7, divide by 7. Cool. And finally, we get x equals 6. Okay, now let's go back to what we were trying to find. Now, were we trying to find the angle, or were we trying to find x? Okay, there it is. Yep, we were trying to find x. Right? Now, always be careful on this, because sometimes, you know, you find something, you think you're done, but it was something else that they wanted, right? But this is just x, so it looks to me like we're good with that, right? So x equals 6, right? Now, technically, look, that ought to be x degrees, shouldn't it? So this actually ought to be 6 degrees. Now, I always like to double check. Now, I could try and redo these equations, and that would certainly be a strategy. But, you know, one way to be really sure is let's put this number back into the picture, right? That's, to me, the best thing to do. So where there's an x, I'm going to put this 6, right? So let's try that. 7 times 6 minus 7. Let's just see if it kind of makes sense based on the picture, right? So 7 times 6, I've got 42 minus 7. I've got 35, and sure enough, I didn't have the degrees there, but right, degrees, that's going to eventually be degrees. Okay, let's just do a sanity check on this, right? 35 degrees. Well, 5 and 5, that's a 10. 3, yep, that's a 90. Okay, now, and just ballpark it, this actually looks reasonable. I mean, you can't assume it's to scale, but it looks roughly 55, and to me, this looks roughly 35. So, you know, I'm feeling pretty good about my answer of 6 degrees, all right? Well, let's keep moving then. And finally, let's do a couple lengths calculations. Now, for the first one, we're going to come up here. Okay, I've got this circle right here. Now, what's happening on this one is, again, I've got a tangent, right? Here's PQ, that's tangent. Well, okay, what do we know, right? We know when it's tangent. Let's go ahead and make it perpendicular. That's the thing we keep using over and over here. Now, I'm not actually trying to find an angle, though, this time, am I, right? It says, what is NQ, right? NQ is this distance right here, right? Well, this must be a right triangle. What do we use with right triangles? Oh, my favorite theorem, right? We're going to use the Pythagorean theorem, right? So let's just do that. And what we'll do is we'll call these, you know, A, B, and C, right? A, B, and C, just to compare to the use of Pythagorean theorem. So I've got A squared plus B squared equals C squared. A squared plus B squared equals C squared. Okay, cool. Well, A, I've got it right there, right? So let's start substituting into our formula. I've got 6 squared. B, we've got 8 squared, and that equals C squared. All right, well, let's just kind of work it through. 36 plus 64 equals C squared. Well, 36 plus 64, that equals 100. Okay. Now, remember, what we want to do is we want to undo this, right? So to undo the square, we take the square root of both sides. Square root of both sides. So by taking the square root of both sides, then this becomes 10 equals C. Now, we usually like to write it with the variable on the left. And so I've got C equals 10. But, you know, I really need to make sure I got those units, right? So let's go back, right? Everything was in kilometers. Let's make sure we have the correct units here, right? 10 kilometers. And again, we've got, this is our answer, right? Double check, right? NQ. Let's write that in there, 10 kilometers. Just kind of sanity check it again. 6, 8, seems good. And you know what? That's actually starting to look familiar. That actually reminds me of one of those Pythagorean triples we have, right? Remember the old one, 3, 4, 5? Well, double that and it's 6, 8, 10. So yeah, I'm feeling really good about this answer. Okay, last one is, now we've got, again, a tangent. This time it's WX, right? WX right here. Tangent, therefore WX tells me that it must be perpendicular, right? Perpendicular. Great. Or, sorry, it's not saying it for sure. Look, there's a question mark there. Ooh, we got to be careful, right? Don't get ahead of ourselves. So really, is it perpendicular? That's the question, right? We're not sure it's perpendicular. I'm just going to kind of scribble that a little bit, you know, and say it might be, it might not be. But if it is, it'll be that. So let's just see if it is. Now, again, we use the Pythagorean theorem again, but this time we're saying, well, let's see if it's true, right? Because look, we have 3 different lengths here. So in theory, it's all true, right? So, but this time we got to put a question mark on it, right? A squared plus B squared equals C squared. Maybe, right? Maybe it does. If it does, that tells me it's a right triangle. If it doesn't, that tells me that it definitely is not a right triangle. So, okay, let's start putting in some numbers. Okay, so A, I'm going to call A this guy right here, 32, right? 32 squared plus 28 squared, right? These are the legs, or what we think are legs. We're not, technically we can't call it a leg if it's, unless it's a right triangle, but they might be legs. And then finally, what might be the hypotenuse is 42. Okay, so let's just work through the left side. Okay, so 32 squared, as it turns out, if I grab my calculator, right, we would just figure that out real quick, right? 32 times 32, right? 1024, we would do that, right? 1024. 28 squared turns out 784. And then 42 squared is 1764. Well, look, if we add these two numbers up, right, 4 plus 4, 8, all this, on your calculator, what you're going to get is 1808. But 1808 is not equal to 1764, is it? Right? So that is not tangent. It's close, right? It's not too far off. But that would not be tangent because it's not a right triangle, is it? Right? That's not a right triangle. Therefore, that is not tangent. It's not tangent because it didn't quite equal what the Pythagorean theorem would have said it would. All right, well, that's it for today, guys, and we will see you in the next video.